In electronics, there are smart decision makers, one of which is the comparator. The comparator is an electronic device that compares two voltages and gives an output, a high or a low output, depending on which input is bigger. There are two input pins, the non-inverting input and the inverting input. The voltage at the positive pin, which is the non-inverting input pin, is greater than the negative pin or the inverting pin. Output goes high. And the voltage at the negative pin is greater than the positive pin. Output goes low. So let's conduct a simple practical example with the LM339 comparator. This IC package contains 4 comparators. Okay, the datasheet shows us its pins and the arrangement. For a very basic example, we'll use one of the comparators to compare two voltages. So we have pin 1 down here at the top left, and we have pin 7 down here at the bottom left. On the breadboard, I already have 9 volts here and ground here, and that would be one of the voltages we would have on the input of the LM339. So we want the LM339 to communicate with us to pass the information of which voltage is higher through an LED. So we would connect an LED to its output. But then we have to understand that the LM339 has an open collector output, which means it can't give us a high of itself. So we have to attach it to a pull-up resistor, okay, which will make the output pin high. We're going to have 12 volts on this rail. I'll bring that in. So we'll have this resistor connect to it to pull up that pin to 12 volts always, except for when the LM339 wants the pin pulled to ground. Then we connect on that same pin our LED. So we'll have pin 3, which is our ground, connect to the negative here. And so we'll bring in our 12 volts from the power supply and put it on this rail, okay, which is the rail that has our resistor. Then we'll bring in the ground for 12 volts, our 12 volts ground too. We put it on the same ground with our 9 volts ground. So we connect our VCC to 12 volts. Our VCC is pin 3. We connect it to 12 volts down here. So we have 12 volts connected to our VCC for the IC. We have our ground connected down there by one wire strip. Alright, then we have this resistor and this LED for our outputs. So because our output is on pin 14, alright, we have to use the comparator which is connected to that output, and that will have to be the comparator on pin 8 and pin 9, okay, which are the bottom pins on the right. So we connect pin 8 to our 9 volts, okay, which happens to be our negative pin to 9 volts, and then we connect our positive pin to 8 volts on this wire. We have 8 volts on this wire, so we connect that to that pin and we turn on our power supply. And as you can see, the LED is off. Let me just quickly read the voltages on the pin for us to see. With my negative probe on the negative wire, then my positive on pin 9, you can see we have 8.37 volts, right? While on pin 8 we have 9.24 volts. So we see that's what we have there, and our LED is turned off. Of course, right now we have the lower voltage on the positive pin and the higher voltage on the negative pin, so we don't have an output. If we swap both wires, okay, so I have just put in 9 volts on the positive pin and I bring in 8 volts on the negative pin, and we see what we get. Our LED lights up. So this is basically how the comparator works. It compares the voltage level on two of its pins and gives out an output on the output pin. Remember, it's an open collector output, and that's why we have this resistor pulling up the output pin, okay, to VCC. If we don't do that, then our comparator wouldn't be able to give us the results we expect. And also, very important that if you're going to use this in a circuit, that every unused pin is grounded, okay, to avoid them being affected by noise. I also didn't bother using the resistor on the output pin because this resistor on the output pin, which acts as a pull-up resistor, also acts as a resistor to limit current flow through the LED, okay, because this LED is actually being fed from VCC, okay. So the duty or responsibility of the output pin of the LM333 is just to pull that pin down to ground when it actually wants to, and by that it would have to pull the voltage across the LED to 0. So the actual resistor I'm using on the output pin is 8.2 kilo ohms. So I'm not using resistors on the input pin because the LM339 input pin has high impedance, and so the pins have low input bias current. So we can even connect the pins directly to ground without any issue. Another thing to know about the input pin of the LM339 is that they have a common mode range from 0 to VCC minus 1.5 volts. Okay, so it means if VCC is 5 volts, the maximum voltage you can place on the input pins would be 3.5 volts. And that's why you see on my input pin, I have 9 volts and 8 volts. I could have used 9 volts and 12 volts, but that would make the IC misbehave. Okay, so whatever you're putting on the input pin has to be 1.5 volts lower than VCC. So as a block of 4 comparators, the LM339 can be used for zero crossing detection, voltage monitoring, battery level detection, and other kind of similar circuits. Okay, so let's build a basic circuit that can monitor voltage and communicate to us about its level via LEDs. Okay, so everything we're going to be doing is basic. Okay, there are certain vital parts that will be left out just so you understand how the integrated circuit of the LM3339 functions. Okay, so here I have my LM339 again. I have 9 volts, okay, on this red wire. Of course, this is ground. I have ground here too, and I have 12 volts here. So I have 12 volts power supply here, positive ground. I have 9 volts power supply, positive ground. I have my LM339, okay, and then this is connection for the ground of LM339. Okay, so that's pin 3 connected to ground. So I'm going to bring in VCC, which is going to be 12 volts. Okay, I'll connect 12 volts from here to this side. Okay, so we have this wire connecting 12 volts from here to this side. So we have 9 volts on the first rail and we have 12 volts on the second rail. So this way I can connect the 12 volt to VCC easily. So I connect all my outputs to the same 12 volts. So I have to move this 12 volts pin down this way so I can have place to place my resistors. So I have all pull-up resistors connected for the outputs. So now I can place the LEDs for each of them. I'll place them in a way I would connect all neutral to the same pin. So I'll connect neutral to this line so we can have this properly arranged. So let's connect the negative pins of the LED to the negative of the circuit. Okay, so let me connect for the remaining LEDs. Okay, so we have the negative pins of our LEDs connected across. So we're going to use a voltage divider to have different voltages on our negative pins while we compare them to the voltage that we want to monitor. Okay, and that will make us know the level the voltage is at, and we can read that off from the LED display. Okay, so let's begin with connecting our resistors to our negative pins based on what we have in our circuit for the voltage divider. So we actually have need for a 34K resistor. Okay, so because I don't have a 34K resistor, I'm using two 68K resistors in parallel. Okay, so that will give us 34 ohms, and we're placing that on our first negative pin, which happens to be pin 4. Okay, and it's going to be connecting straight to VCC, which happens to be 12 volts. Okay, so we have this connected to our 12 volts VCC. Let's not forget that this column here is our 9 volts, and this one here is our 12 volts VCC. Okay, so that's the first resistor on our voltage divider, which happens to be 34K. So we're bringing in the next, which is a 5.6K resistor, and we'll connect the negative pin of the first comparator to the negative pin of the second, which happens to be 4 and 6 respectively. So next we connect pin 6 to pin 8, and then we connect pin 8 to pin 10, which will then be connected to ground. Okay, via this small wire, we'll connect pin 10 to ground. Okay, so you can see that from our circuit, our voltage divider circuit is complete. So the last thing we're going to do is connect all our positive pins to the voltage we want to compare to our negative pins. So let's connect pin 9 to pin 11. Then we connect pin 7 to pin 5. Okay. So we connect both pairs to our 9 volts. We connect both of them to our 9 volts power supply. Okay, so we just connected our multimeter to this rail, so we get to see we have 9.13 volts. So let's see how the change in this voltage will affect our LEDs. So let's turn on our power supply, our 12 volts VCC. Okay, so we already see we have only 3 LEDs on. Okay, so as we turn the knob, okay, so as we adjust our voltage, we can see the response of the LED. So at about 8.5, we have another LED turned off, and about 7 point something we have the next LED turn off. Okay, so the last LED would not go off, because for it to go off, the voltage will have to go below 0. Since we have 0 at the negative, we have ground connected to the negative pin of that last comparator. Okay, so we move up and we have them come back on. So we move down and they go off in turns according to our voltage level. So we can see how the comparator can be used to monitor voltage, and we can also use this kind of setup for battery level detection.